Hello, today we are going to solve the question number 30 of IIT JAM Mathematics 2019. Let an be a sequence of positive real numbers such that a1 is equals to 1 and an plus 1 square minus 2 an multiplied by an plus 1 minus an is equals to 0 for all n greater than equals to 1. Then the sum of the series, the sum over an divided by 3 to the power n, where n is equals to 1 to infinity, lies in which of these intervals? Here we are given four options and we need to find the correct one. Okay, so let's start the solution. Let an be a sequence of positive real numbers such that a1 is equals to 1 and an plus 1 square minus 2 an plus 1 minus an is equals to 0 for all n greater than equals to 1. Therefore, we can say that an plus 1 is equals to 2 into an, like a quadratic equation. The solution of a quadratic equation is 2an plus minus root over 4an square plus 4an divided by 2. Okay, and this reduces to an plus 1 is equals to an plus minus root over an square plus an, and since an plus 1 square is positive, so an plus 1 only take the positive value, that is an plus root over an square plus an, and from this we can write an plus 1 is equals to an plus an root over 1 plus 1 by an. Okay, now since an is greater than equals to 0, therefore we can write that an plus 1 is greater than equals to 2an. Okay, and since an is greater than equals to 1, this implies root over 1 plus 1 divided by an is less than equals to root over 2, and this implies an plus 1 is less than equals to an multiplied by 1 plus root over 2. Okay, so 2an is less than equals to an plus 1 is less than equals to an 1 plus root over 2. Now using this portion, that is 2an is less than equals to an plus 1 for all n greater than equals to 1, we get for the value of n equals to 1, 2a1 is less than equals to a2. For n equals to 2, we get 2a2 is less than equals to a3. Therefore, we can write 2an minus 1 is less than equals to an, and when we multiply all inequalities, we get 2 to the power n minus 1 a1 is less than equals to an, and as we know that an is equals to 1, a1 equals to 1, we can write that 2 to the power n minus 1 is less than equals to an. Okay, again if we use an plus 1 is less than equals to an multiplied by 1 plus root over 2 for all n greater than equals to 1, and if we take n equals to 1 we get a2 is less than equals to a1 multiplied by 1 plus root over 2, and if we take the value of n is equals to 2 we get a3 is less than equals to a2 multiplied by 1 plus root over 2. Therefore we can generalize it, an is less than equals to an minus 1 1 plus root over 2, and multiplying all inequalities we get an is less than equals to 1 plus root over 2 whole to the power n minus 1. So we get 2 to the power n minus 1 is less than equals to an multiplied less than equals to 1 plus root over 2 to the power n minus 1. Okay, and this implies 2 to the power n minus 1 divided by 3 to the power n is less than equals to an by 3 n divided by 3 to the power n, because we need to find sum over n equals to 1 to infinity an by 3 to the power n. That's why we divide all the terms in this inequality by 3 to the power n, and if we take sum in each of these portion we get an divided by 3 to the power n, where n equals to 1 to infinity and it is less than equals to sum over n equals to 1 to infinity 1 plus root over 2 whole to the power n divided by 3 to the power n multiplied by 1 divided by 1 plus root over 2, and this can be write in this way, that is half 2 to the power n divided by 3 to the power n is less than equals to n equals to 1 to infinity an divided by 3 to the power n is less than equals to n equals to 1 to infinity 1 plus root 2 whole to the power n divided by 3 to the power n multiplied by 1 plus root over 2. Okay, now from this step if we use the infinite GP series formula we get 2/3 divided by 1/3 is less than equals to sum over n equals to 1 to infinity an divided by 3 to the power n is less than equals to 1 by 2 minus root 2. Okay, therefore we get 1 less than equals to sum over an divided by 3 to the power n is less than equals to 1 by 2 minus root 2, which is less than 2. Therefore the value of the required series is between 1 to closed 2. Therefore the correct answer is the option A. Okay, so that's all for today. Thank you very much.